Okay, in this section, we're going to talk about the area under the curve. So we start out pretty basic, and in the basic section, which is the first page, you should be able to figure out the area under the curve just by doing basic geometry. So doing length times width, you should find that the area of this rectangle labeled R is just 8 units squared. So that's our first page. Let's get on to our second page. Okay, in the second page you see that you have a shape that is not just a rectangle when you try to estimate the area, but instead you should turn this into a triangle right there and a rectangle. So when you do those two areas, so I'm going to say the area of the rectangle plus the area of the right triangle, you should be getting an area that's equal to 8. They're each 4, and I'm going to leave that to you to figure out. Here comes the new information. This is called a definite integral, and it's the way we express the area under the curve, which is the second half of our course. The first half was derivatives, which is slope. The second half is integration, which gives us area under a curve. So since this function is the function f of x equals 2x, to indicate we want to take the area, we would do it this way. Now, it's a definite integral because it has endpoints of that are indicated, and they are 1 and 3. If it didn't have endpoints, it would be called an indefinite integral. So that's some vocab for you, and you can express the area as the answer to the indefinite or to the definite integral. So that's some notation, and now we're talking calculus. Let's go on to the next page. Okay, here they give you a function, and they only define it as the function h of x. So they ask you to explain how you would get the area, and again you would draw a little triangle here by drawing straight lines, a horizontal line and a vertical line. And so to explain how you would get your area, you would say the area of the big rectangle plus the area of the triangle. And when you figure that out, and I'm going to leave that to you, you should get 13 square units. Now, can we express this using the notation from the previous page? And you should be saying, yes, I can. Here is your integral symbol. -2 is your endpoint. 4 is your other endpoint. Your function is h of x. And you always add a dx because you're taking the derivative. You're undoing the derivative with respect to x, really. And your answer is going to be 13 square units. So that's how I would express the area using good calculus notation. Okay, let's go on to the next page. Okay, the concept of approximating the area under the curve using nice little triangles and rectangles falls apart right now. Why does it fall apart? So can you determine the area of the region using the same approach we have done previously? And the answer would be no. So let me just get this down so we can see our function. Okay, why is it no? Well, it's no because if you can draw a nice rectangle, but your triangles end up having not straight lines, and therefore you're not going to be getting a triangle that you can find the area of by saying 1/2 base times height. So why is this more difficult? It's because of the curves. Can you write the expression that represents the area of this region? And you should be able to. So what are we going to do with that? So to write the expression, here's your integral symbol. What are your endpoints? It looks like -1 to 2. What is your function? And they give you the function is 1/2 x squared plus 1. And we're always going to put the dx after a function. So there's your function, there's your dx, and that's how I would write that expression for area. I don't know what that area is, but I do know how to write an expression for it. So let's go on to the next page and see if we can figure out how to approximate the area under an irregular shape. Okay, so now we're going to talk about Riemann sums. So I'm going to write this right here. And I have changed this document, so yours may not reflect the change yet. I didn't change this document so that you can see where I'm making changes. We're going to first divide this shape under this curve into rectangles, and they're going to be rectangles of equal width, and they want 3 of them. So this is what we're going to do. Here's your formula for figuring out how we're going to do that. We're going to set b minus a over n will give me the width. So what is b? B is the high endpoint, so 2, minus a is the low endpoint, so it's minus a minus 1, and they want 3 rectangles, so n is rectangles. So 2 minus a minus 1 is 3, so 3 over 3 equals 1, and therefore the width of each of those rectangles, will be 1. So that means that here are the vertical parts of my rectangles, and I have 1, 2, 3. Okay, if we're going to use left Riemann sums, and that's our approach initially. So again, I have written lower here, but we're going to talk about left Riemann sums. So I'm going to tell you that doing left Riemann sums, we're going to work on this part of our table of values. And you can get this from your table command on your graphing calculator, and you can set your table to go up by ones or by 1/2 if you go to table set. So the 2 commands that you're going to need on your calculator are table and table set. Okay, table, and I'm going to write it out so you see what it is. Table set. Okay, table is above graph and table set is above windows. So if you're going to do left Riemann squares, so we're going to do left. Oopsies. Okay. I can't write left there. So let me just erase this, and we're just going to say left. Left Riemann squares. Okay, so I'm going to go up the furthest point left on my domain. And once I go up, I'm going to go across horizontally to the next increment. That's my first rectangle. Then I'm going to go up to the curve and go across horizontally. That's my next rectangle. Once again, up to the curve, across horizontally. That is my third rectangle. All right, how do I get this area? Well, each of the bases is equal to 1. So to get this area right here, I'm going to take 1 times what is the height when your x value is -1. Well, that height is 1.5. So this is 1 times 1.5. And that's my first rectangle. Then let's change colors. We'll go here. To get my second rectangle, I'm going to say 1, because that's always my base. Here's my base right there, and right there, and right there, always 1. 1 times what's the height when my x value is 0. That height is 1, so 1 times 1. The third rectangle is going to be right here. Here's your base, so it's going to be 1, because that's all the bases, times what is the height when my x value is 1.5 is 1. That height is 1.5, so this is also 1 times 1.5, just like our first rectangle. So what is the sum? Well, that's 1.5 plus 1 plus 1.5, so that's 4. So it's 4 units is the sum of my triangles when I draw them from the left. So that's the left Riemann sum. Okay, and it looks like I am going to probably underestimate, but I don't know for certain until I do my right Riemann sum. So let's do the right Riemann sum on the next page. So again, we're not going to call it upper and lower, we're going to call it right and left. So I'm going to do a right Riemann sum on this page. So to do the right Riemann sum, what you do is, and let me change color again, you come up not from the end point, the lowest end point, but from 1 over. So I'm going to go to the 0 because that's our next increment. Come up and then go to the left. Okay, come up, go to the left, come up, and go to the left. When you go to the left, you stop at the next increment. So here are your right Riemann sum rectangles. Okay, so if you want to calculate that area, let me just turn to my page, I am going to get 5.5. How will I do that? Well, let's go back for a second, and perhaps we'll use the purple to box out where I'm looking. I am now looking here. So I'm going to say 1 times 1 plus 1 times 1.5 plus 1 times 3. So that's 3, 4.5, 5.5. So going back, I get I'm going to call it a right Riemann sum of 5.5. Now the right Riemann sum is more than the left Riemann sum, so we could say that the right is the upper, so this happens to be the right this time, and the left is the lower. But really, I want you just to understand the left and the right. So what's your average? Because that's the best value. So 4 plus 5.5 is 9.5 divided by 2 ends up being 4.75, and that's our best approximation of the area under those curves. Okay, so you can read the information one more time to make sure it makes sense. Don't focus on lower and upper. Focus on left and right. It's really more important. Once we have both the left and the right, we can determine which one is higher and which one is lower. But basically, I want you to understand how to get the left and the right. So let's continue on the bottom of this page. So what I'd like to do is I would like to take this curve right here and copy it to the top of the next page so that we can do the left and right Riemann sums while still looking at the picture. So let me try to set that up on the next page. Okay, so for this graph, I have the graph above, and what is that graph? So that's the function f of x equals 4 minus x squared. So there it is. And we're going to create a table of values. So how will I do that? Well, I'm going to use my graphing calculator. In the y1, I'm going to put 4 minus x squared. And then what I'm going to do is go to second table set and start at 0 and go up by, let's see what I'm going up by, 0.5. And I will then get the rest of the values. So let's fill them in. This value right here should be, well, let me do it above. So let me undo that. Let's see how we can do this. Let's make this a little bit bigger. And can I, yeah, I think I can. Okay, so this value should be 3.75. So if you can write in 3.75 there, that's a missing value. And here's another missing value, and that you should be getting 1.75. So play with table set and table and make sure that you can get that. Now, instead of saying lower Riemann sum, we're going to say left Riemann sum. And I'm going to do that in red for you. I need to have 4 rectangles, so that means I need to have another hash mark here and here because that's going to match my table of values. So if I'm going to do the left Riemann sum, I'm going to come from the left, I'm going to hit the graph and then go over to the next hash mark. I'm going to continue in that fashion. Come up from point 5, hit the graph, which is right here, and go over, go over to the next hash mark, come down. Then for the next rectangle, I'm starting from 1, I hit the graph, and I come over to the next hash mark, which is 1.5, and then I go from 1.5, I hit the graph, and come over to the next hash mark, which is 2. So the red are my left Riemann sum rectangles. So to figure out what they are, using my table, each of my bases is 0.5, so I would say 0.5 times 4 plus 0.5 times the 3.75 plus 0.5 times 3, so that's right there, because that's my height, my y values are my heights, plus 0.5 times, what comes next? The 1.5. Excuse me, the 1.75. I'm doing y values and not x values. So if I sum all of those up, my left Riemann sum will be 6.25. And I have used these values in red. Okay, let's change. Maybe I'll change to a blue color. And let's do the other set of rectangles. I'm going to do them right on top. And again, this is not going to be the upper. This is going to be the right Riemann sum. So I'm going to start not from the 0, but from the 0.5. I'm going to come up, I'm going to hit the graph, and that's my first rectangle right here in blue. For the next one, I come up from the 1, and I hit the graph, and here's my next rectangle. So you can compare these to the red ones above. For the third rectangle, I come up from 1.5, I hit the graph. Here's my another blue one. And then for the last one, I come up from the 2, but when I hit the graph, I don't really have a rectangle, do I? So I'm going to use these rectangles. So let's see if we can find what the multiplication looks like. So I'm going to say 0.5 because that's always my base, and now this time I'm going to not start with the 4 but start with the 3.75 plus 0.5 times the 3 plus 0.5 times the 1.75 plus 0.5 times the 0. So my right Riemann sum will be equal to 4.25. Okay, so since I don't know where I stopped talking, I have done the left Riemann sums in red and the right Riemann sums in blue. I have a left Riemann sum of 6.25, a right Riemann sum of 4.25, and in this situation, the left Riemann sum is the greater number, so that's going to be the upper Riemann sum, and the right Riemann sum is the lower number, so that's going to be the lower Riemann sum. So on the next page, we'll talk about the average and what the best approximation will be. Okay, so using the numbers we just got, whoop, I'm on the wrong, let me see if I'm on the wrong photo. No. Yes, let me get another photo and I'll be right back. Okay, this is where I want to be. So the average is the average of 6.25 and 4.25. So that average, I believe, is going to be 5.25. So what we did by hand was lower Riemann sum, let me backtrack, was left Riemann sum, right Riemann sum, and then we took the average. And we've done all this by hand, not using the calculator. And this ends video number 1.